Hello everyone, now let's continue our course with our next topic, that is graphs. So before also we have discussed some points about graphs, that graph is being implemented in Facebook, like users are acting like an vertices and connection between two users acts like an edges. So let's continue with that point and see in detail what actually the graph is. So first we will see the typical definition of graph. Let me select my pen. So what is graph? A data structure that consists of a set of nodes, vertices, and a set of edges that relates the node to each other. Here, like Austin, Dallas, Denver, Washington, Atlanta, Houston, Chicago, this all could be called as nodes or vertices. And as you can see, Austin is connected with Dallas and Dallas is connected with Denver. Chicago is connected to Denver. So what is this connections? These parts I have drawn, these are actually called as these are actually called as edges. So Austin to Dallas there is one edge, and Austin is one edge. Then Washington, Atlanta to Washington is one edge, and likewise the edges are formed here. So this is how the graph is defined as. Graph consists of certain number of vertices and certain number of edges. Let's move further. Now what is the formal definition? A graph G is defined as follows. G equals to V, E. So here V denotes the number of non-empty set of vertices, or you can say it as a finite set of vertices. Like we have seen there, the finite set of vertices can be Austin, Washington, Atlanta, and here edges. E denotes the set of edges or pairs of vertices. Like we have seen from Austin to Dallas, there was one edge. So likewise, E denotes a set of edges where any two vertices are connected. Now let's have a look on directed versus undirected graph. So what is undirected graph? When the edges in a graph have no direction, the graph is called as undirected graph. Like here in this graph, there is no direction denoted in this edges. Like here we could not define the edge between A and B, whether it is starting from A and ending at B, or it is starting from B and ending at A, right? So graphs which aren't having any kind of directions, where the edges could start from any vertex and end up at any vertex, those graphs could be called as undirected graph. And the set of vertex of these graphs could be represented as follows, like A, B, C, D, and the set of edges consist of sets like this, like one edge from between A and B, that is AB, AD, BC, and BD. Let's move further. Now we will see the directed graphs. So directed graphs are completely opposite of undirected graphs. These are the graphs which consist of directions in it. Like here, you could see the age between 1 to 3. There are two ages which we are going to see. Like there is the first age which starts from 1 and ends up at 3, and the another age which starts with 3 and ends up at 1. So this is the directed graph because direction is specified here. It is starting from 1, ending at 3, likewise. So you could write the set of edges as follows. First will be 1 to 3, then 3 to 1, then 5 to 9, then 9 to 11, and then 5 to 7. So these are the edges of directed graph. But here you could see that one thing you have to just keep in mind, that if the graph is directed and the order of the vertices in each edge is important, because here you could see that this is one vertex 9 and it is forming the edge with itself only. This is called as self loop. We will see it further. Now, trees versus graph. So, trees are the special cases of graphs. Like here, it is a binary tree because you could see there are two childs of each parent. So, this is the binary tree, and here, graph is a directed graph because taking example the age between G and D, here the age starts from G and ends up at D. That's why it is called as directed graph. And here this is the set of vertices and this is the age of graph. Now what is the graph terminology? The first terminology we are going to see is the adjacent nodes. Two nodes are adjacent if they are connected by an edge. Like here the age is between 5 to 7, but you could notice that 5 and 7 stands on the same edge, right? So these are known as adjacent nodes. Like 5 is adjacent to 7 and 7 is adjacent from 5. Now what is path? This is the second terminology. Path is something which connects the two nodes. Like here is one path. 5 to 7, this is one path. Now what is a complete graph? Complete graph is actually a graph in which every vertex is directly connected to every other vertex. Means there is no such kind of vertex present there which don't have any kind of edges, right? Now let's move further. What is the number of edges in a complete directed graph with n vertices? Actually, this is the question which are being asked in interviews, so let's focus on it. What is the formula to calculate the edges of directed graph? You could see here there are 4 vertices. Okay, and it consists of certain kind of edges, certain number of edges. So how to calculate it? The simple formula to calculate it is n into n minus 1. So here, how many vertices are there? 1, 2, 3, 4. So 4 vertices is there. So 4. 4 into 4 minus 1. What is 4 minus 1? It is 3. 4 into 3, 12. So how many edges it is consist of? It is consisting of 12 edges. This is how the edges are calculated. And what about this big O of n square? It is a time complexity of graph. You can study how to calculate the time complexity in algorithm analysis. Okay. Now, what is the number of edges in a complete undirected graph with n vertices? Now, this is the undirected graph. As you can see, there are no directions between any two edges, any edges between two vertices. So, how to calculate the edges of this graph? The simple formula to calculate the edges of this graph is n into n minus 1 divided by 2. Like how many number of vertices we have here? 1, 2, 3, 4, 5. So there are 5 vertices. Now how to calculate the edges? 5 into 5 minus 1, that is 4, and 4 divided by 2 is 2. So it is 5 into 2. 5 into 2, it is 10. So there are 10 edges into this particular graph, into this particular undirected graph. Remember. So these two formulas you have to keep in mind to calculate the number of edges. Now what are weighted graphs? Weighted graphs are the graphs in which each weight carries a value. For example, see this age between Austin to Dallas. Now this age is having 200 value, right? Also take a look on this age from Dallas to Denver. It is having 780 as a value. So if the ages are having certain kind of values, those graphs are called as weighted graph. So now let's see the graph implementation. For implementing graph, you need two methods. One will be the method that you will implement this graph using array, or you could also implement this graph using linked list. So first we will see how to implement it using array. So you need here two arrays. One will be the 1D array and the next one will be the 2D array. So 1D array is basically used to represent the vertices, whereas 2D array is used to represent the edges. And this method is known as adjacency matrix. So let's move further. First, you just look onto this graph. You could notice here that Austin is connected with Dallas. There is an age between Austin and Dallas, and value of that age is 200. And likewise, the further ages are also present where the values are given. So you could see that this is a weighted graph. So what we will do, we will implement this weighted graph using 1D arrays and 2D arrays. So let's move further. So here, what I did, this vertices which we have seen before, that is Atlanta, Austin, Chicago, Dallas, and further on. So these vertices I stored in 1D array. As you can see, Atlanta is stored at 0th index position, Austin is stored at 1st index position, and respective vertices are stored at the respective indexes. So likewise, you could store these vertices into 1D array. And what is this? This is 2D array. So 2D array is basically used to show the ages, right? To represent the ages. So how we will represent ages here? Like we have to take indexes over here also. 1, 2, 3, 4, 5, and 6. Okay. Now, just concentrate here. What I am going to do is, we will take one example like this Washington. Now this Washington is forming edges with how many vertices? 2, right? One is Dallas and the another one is Atlanta, right? Having the weights 1300 and 600, right? So now we will see how to represent this Washington and its weights. So what we will do here, it is Washington to Dallas and Washington to Atlanta. Okay, let's consider Washington. Where is Washington? At 6th index position. And where is Dallas? Here. So first we will see Washington is at 6th index position, means here. And Dallas is at 3rd index position, means here. So is there 1300 present? Yes, it is present. Right? Now the next one is Washington to Atlanta, right? It was Washington to Dallas, sorry. So let's consider from Washington to Atlanta, because we have considered Dallas at the first. So for Washington to Atlanta, what we will do, it is 6th index position and Atlanta is at 0th index position. So at 6th index position and 0th index position, right? It is 600 and it's true, right? We were having their 600 value, which is the age between the Washington and Atlanta, and it was 600, which is represented over here. So wherever there are weights present over there or ages present over there we are going to write the weights of respective ages. But if it is found that there are no kind of ages present over between two vertices or two nodes, so we will write 0 there. Okay, hope you got this. Now we will implement graph using linked list. So for implementing graph using linked list, what we will do, we will take 1D array and we will take a singly linked list. So 1D array will be used for the same reason to represent the vertices, whereas the list or the singly linked list is used for each vertex V, which contains the vertices which are adjacent from V. And obviously, this method is called adjacency list. You have to keep this in mind. So again, we will take the same graph and the same example. So Washington to Dallas, it is 1300. Washington to Atlanta, it is 600. So now let's represent it using singly linked list. So in adjacency list, what happens actually, as we have taken the same example, Washington to Dallas and Washington to Atlanta. So what is the age value we were having from Washington to Dallas from 6th index position to 3rd index position? So we will see. So this is the 6th index position and 6th index position to 3rd index position means this node, right? So in this node, what it represents the age value, that is weight, that is 1300, which is present between Washington, and this 3 represents the Dallas. So between Washington and Dallas, it is having 1300 the age value, or you can say the weight of the age. Likewise, between Washington to Atlanta, if you want to find between Washington to Atlanta, then what you will do, it is at 6th index position, right? And Atlanta is at 0th index position. So take a look on this node. Here 0 represents the Atlanta, whereas 600 represents the weight of the age which is present between Washington to Atlanta. So this is how the graph is implemented using singly linked list and 1D array. 1D arrays are to store the vertices, whereas singly linked list is used to represent the edges. Keep in this mind. You could either take this syntax in consideration, means you could just assume that index of adjacent vertex will be the first part, the second part will be the weight, and the third part will be the pointer to the next edge node. But remember, this is not a doubly linked list. This is a singly linked list. Don't get confused here. Okay. Next one is adjacency matrix versus adjacency list. We will compare these two methods and which one is efficient we will see over there. So it is in adjacency matrix, it is good for dense graph, whereas adjacency list, it is good for the sparse graph. So what are sparse graphs? Sparse graphs are the ones where the zeros are present more. Means if the zeros, there are more number of zeros, then it means that there are less number of edges, right? Because where there were edges, we were writing the weights, whereas where there were no edges, we were writing the 0. So as number of 0 increases, edges decreases, right? So it is good for the sparse graph. This is the only meaning of adjacency list. And what is adjacency matrix? It is very, very efficient or good for the dense graphs. Means where the number of edges are greater. So what is this memory requirement? It is actually the space complexity. So what you will consider that memory requirement of vertices plus memory requirement of edges will equal to the memory requirement of the adjacency matrix. In the same order, in adjacency list, the memory requirement for the vertices plus memory requirement for the edge will be equal to the adjacency list. So remember that the space complexity of adjacency matrix will be big O of V square, that is big O of vertices square, and big O of V of adjacency list. And obviously the connectivity between two vertices can be tested quickly, whereas in the vertices adjacent to another vertex can be found quickly. So these points you have to just keep into mind. Now we will see one example on graph searching. But let's understand why graph searching is done. Suppose you want to find a path between two nodes of the graph. For example, Washington and Austin, like we have seen the example before. So in that example, what was there? Washington was having edges with Dallas as well as with Atlanta. But it was seen that Washington was not having any kind of edge with Austin, right? So in this case, if you want to generate a edge between Washington and Austin, so you will use graph searching. Means you will use graph searching, or what you will do in graph searching, you will search such a kind of path so that you could start with Washington and you could reach towards the Austin. So for that, there are two methods. One is the depth first search and the another one is breadth first search. So let's see them one by one. So in depth first search, the idea behind depth first search is that it travels as far as you can down a path. For example, you could just take the example of stack over here. So in that stack, suppose this is my stack and you want to search the path between two nodes. So what you will do, you will travel as far as you can down a path, right? So here, until you reach a dead end means until you reach the next vertex which has been marked, or there is no next vertex until you reach to the end, the backtracking is done. So likewise the depth first search works. It finds out the path between two nodes and it gives the result, right? In the next one, it is the breadth first search. Suppose you are having one a singly linked list, or you can say there are some nodes present over here. So there is no path between two nodes, and you want to find out the path to travel from this node to this, suppose. So what you will do, you will use the breadth first searching. Means you will search, you will look all the possible paths at the same depth before you go at the deeper level. So here, back up as far as possible when you reach a dead end. What is dead end? Dead end means the end of the singly linked list, end of the graph. Sorry, you have to say the end of the graph. Whether it is consisting of the adjacency matrix or adjacency list, you have that those are the implementation of graph. In that way, the graph is implemented. Sometimes you use array, sometimes you use linked list. So in that, what graph searching is done for finding the paths between the two nodes so that you can travel from the one node to another, right? So hey guys, thank you so much. I'll see you in the next class.